Good afternoon, everyone. So today we'll start new chapter, differential equation. So we do section 9.1 till 9.2.2 with one example, and then we continue with exercise 9.1. So at first we see introduction, what is differential equation, then some basic concepts, that is what is order of a differential equation, and then degree of a differential equation. That is the two most important things for to define a differential equation. Then we do example 1, and at last we do exercise 9.1. So what is differential equation? As its name suggests, it is some kind of equation which involving differentiation. Okay, so for a given function g, find a function f such that dy by dx is equal to gx, where y is equal to fx. An equation of the form 1 is known as a differential equation. So at first understand what is equation 1. So equation 1 is dy by dx, differentiation of y with respect to x, is equal to some function gx. Okay, so we have given a function gx. So find a function f. We have to find a function f where f is y is equal to fx. So such kind of equation involving differentiation of a dependent variable with respect to independent variable with respect to y with respect to x is called a differential equation. Okay, so we will study some basic concept related to differential equation, general and particular solution of a differential equation. So we see what is different. First we understand what is differential equation, some basic concept like order and degree, and then we see how we solve the differential equation, its general solution and its particular solution. So an equation involving derivatives of a dependent variable with respect to an independent variable is known as a differential equation. So any equation in which there is a term involving differentiation, like term like dy by dx, so d2 by dx2, such kind of term involving, that is derivative of a dependent variable. There is a dependent variable with respect to independent variable. So what is called dependent and independent variable? So dependent variable, a variable whose value depends on another. Okay, and we understand by its name as it called dependent variable. So any variable which is dependent upon another variable. Okay, for example y. And what is independent variable? A variable like x that is changed or controlled. It means we change x, and with respect to y changed accordingly x. So we can control x. Okay, so your x is a independent variable. For example, we can write dy by dx. So here y is your dependent variable which depend upon the independent variable x. We take the values of x. So x is an independent variable. We can change x and we control the value of x. So here x is your independent variable and y is your dependent variable. So some example of differential equation. First one is d2y by dx2 plus y is equal to 0. Okay, So this is an equation, and it is not a normal equation, but in this equation there is a term d2y by dx2, which is a derivative of dependent variable, that is y, with respect to independent variable, that is x. And it is not a single time differentiation, it's a double time differentiation, d2y by dx2. We differentiate y with respect to x two times. We get d2y by dx2 plus y, and that is the differential equation, an example of differential equation. In the similar way, second one is dy by dx2 whole dy by dx whole square plus 2y is equal to sin x. It is an equation and involving a term dy by dx, and that is differentiation of y with respect to x. Okay. So any equation involving differentiation derivative of a dependent variable with respect to independent variable is called differential equation. Third, dv by derivative equal to k delta square by v delta x square. So this is also an differential equation. Okay. Here you can see here is two independent variable. In the first two example, there is only one independent variable, that is x. But in example 3, here there is two independent variable, x and t. So v is dependent upon these two independent variable, that is t and x, and we find a differentiation of v with respect to t and also with respect to x. Okay. So the third type is called partial differential equation, and the first two is called ordinary differential equation. So in which there is only one independent variable, that is called ordinary differential equation, and in which differential equation there is two or more independent variable in which the dependent variable is dependent. That type of differential equation is partial differential equation, which is beyond the scope of this chapter. We already consider the ordinary differential equation. Okay. So we will focus on ordinary differential equation with one independent variable. Okay. So we only focus on OD, that is ordinary differential equation, ODE, with one independent variable, only one independent variable. Okay. So if a variable is dependent upon more than one variable, that type of differential equation is PD, that is partial differential equation. So but we only see what is ordinary differential equation with respect to only one independent variable. So notation of some term. So dy by dx can be written as y dash, derivative of y with respect to x. That's how we represent a differentiation of y with respect to x, dy by dx. When we differentiate y dash with respect to x, we get d2y by dx2. We just differentiate dy by dx with respect to, again with respect to x. So we get d2y by dx2, that is y double dash. Okay. Similarly, when we differentiate y double dash with respect to x, again we get d3y by dx3, that is y triple dash, that is derivative of y double dash with respect to x. In a similar way, when we differentiate y n times, that is a different derivative of y the power n minus 1 with respect to x, we get dny by dxn, that is y the power n. That is just a notation, how we denote terms involving differentiation with respect to independent variable in equation. Okay. So first basic concept is order of a differential equation. So to define order of a differential equation, the order of a differential equation is the order of the highest order derivative appearing in the equation. Okay, so just break the this statement. So if we want to define order of a differential equation is the order of the highest order derivative appearing in the equation. Okay, so if there is given an equation or differential equation, we have to show which one is the highest order derivative, and the order of that term is called order of a differential equation. How to find the order? So to find, identify all the derivative present in the given differential equation. For example, there is a term involving dy by dx, d2y by dx2, d3y by dx3. So the highest order among all the derivative determine the order of the differential equation. So for example, if there is an equation like dy by dx plus x is equal to 0. So there is only one term involving derivative, that is dy by dx. So in this case, the order is the order of that highest order derivative, and that is dy by dx. So order is 1. But in case there is a term involving derivative present in the equation is dy by dx, d2y by dx2, and also d3y by dx3. So in this case, the highest order among all the derivative is d3y by dx3. So in this case, the order is 3 for that differential equation. Okay. So example 1 is find the order of differential equation dy by dx is equal to ex. So just carefully observe the equation. This is an example of differential equation, and then see which term is a term of derivative. Like there is a term dy by dx, and then see is this only the term present in the differential equation, and what is the order of that term, and that order is the order of the differential equation. Okay, so we have given dy by dx is equal to ex. That is a differential equation, and highest derivative in the given differential equation is, there is only one term involving derivative, that is dy by dx, and its order is 1. Only one time differentiate y with respect to x, so order of this is 1. So therefore order of the differential equation dy by dx is equal to ex is 1, and that is the order of the differential equation. Okay, so second example is find the order of the differential equation d2y by dx2 plus y is equal to 0. This is a differential equation. So what is the order? So we have given d2y by dx2 plus y is equal to 0, an example differential equation, and the highest derivative given differential equation is d2y by dx2. There is only one term involving derivative. Okay, so the order of this is this term d2y by dx2. So we differentiate y with respect to x, we get dy by dx, and then we again differentiate dy by dx with respect to x, we get d2y by dx2. So order of this is 2. We differentiate 2 times. So order of the differential equation is d2y by dx2 plus y is equal to 0 is 2. Now, the second basic concept is degree of a differential equation. So, the degree of a differential equation is the highest power of the highest order derivative. Okay. So, to define degree of any differential equation, that is the highest power. What is highest power? Positive integer exponent of the highest order derivative. So, to find degree, at first you have to find the highest order derivative. Then the power of that highest order derivative is degree of the differential equation. The differential equation must be a polynomial equation in the derivative. So to find degree of a differential equation must be written in the form where all derivative appear as polynomial term, that is polynomial equation. What is the meaning of this line? This means no square root of derivative, no trigo, log or exponential applied on derivative, no fractional power of derivative, no derivative in denominator. Okay, so if the differential equation, it is the form of polynomial equation in its derivative, like the polynomial form of polynomial is a naught plus a1x square. So in place of x there is a term involving y dash, y double dash, y triple dash, and it is of the form of polynomial equation, then only we can find the degree of the differential equation. But if this is not in the form of polynomial equation, that means there is a term involving square root, but there is a term that is differentiation in the denominator, the the derivative involving radicals, or like we write, there is written as sine y dash, log y double dash, that kind of, that is not a form of differential equation. In that case we cannot define the degree of a differential equation. So degree can be not defined. Order is always defined for a differential equation, but degree can be defined or not defined. Okay. So to find the degree, first task is find the order of the differential equation. Ensure the equation is a polynomial in derivative. So first task is just find the order of the differential equation, and we already know how to find the order of the differential equation. When you get the order of differential equation, the first thing is ensure the equation is a polynomial in derivative. Okay. And then the polynomial derivatives means if term like sine y dash e the power dy by dx or log d2y by dx to exist, in this case degree is not defined. Okay. So if in the differential equation there is a term like all this type, then the degree of differential equation is not defined. Or if any case we apply the algebraic manipulation and convert the equation into the polynomial equation, then we can also find the degree. If it is a polynomial, find the power of the highest order derivative. So when we calculate the order, the term involving the highest order derivative, the power of that term is degree. This power is the degree of the given differential equation. So for example, find the order and degree if defined of each of the following differential equation. So given differential equation is d3y by dx3 whole square plus 2 d2y by dx2 whole cube minus dy by dx plus y is equal to 0. So this is an ordinary differential equation. Why? Because there is only one independent variable and one dependent variable. Dependent only depend upon x. Y is only depend upon x. Okay. So this is a form of ordinary differential equation with one variable. Okay. And now we have to define order and degree. So to define order, just see the highest order of derivative involving in this equation. And to define degree, at first find the order, and to get degree, we have to ensure that this is an polynomial equation involving the terms of derivative, that is y double dash, y triple dash. Okay, so just try. So we have given d3y by dx3 whole square plus 2 d2y by dx2 whole cube minus dy by dx plus y is equal to 0. So highest order derivative in the given differential equation is d3y by dx3. Okay, so order is 3. There is a term that is the highest order derivative, that is d3y by dx3. So the order is 3. We differentiate y with 3 times. First we get dy by dx, then we again differentiate dy by dx with respect to x, we get d2y by dx2. Then we again differentiate d2y by dx with respect to, we get d3y by dx3. So the order of this term is 3. So the order of the differential equation is 3. Now, to find degree of this differential equation, as we can see, the given ordinary differential equation is in polynomial with the term y triple dash, y double dash and y. Okay, it is of the form of polynomial. So we can define degree. So what is degree? Degree is the power of highest order derivative. And in this question, the highest order derivative is d3y by dx3, and the power of d3y by dx3 is 2 in this differential equation. So degree of this differential equation is 2. Okay, there is a confusion that sometimes we can think that 3 is the degree of this differential equation, as 3 is the highest power present in this equation. But that is wrong. We have to see the highest order derivative present in that equation and the power of that highest order derivative is the degree of the differential equation. Okay, so here that is 2. Now find the order and degree, if defined, of each of the following differential equation. Equation is dy by dx plus sine dy by dx is equal to 0. So try this question. So we have given that dy by dx plus sine dy by dx is equal to 0. That is the given differential equation. And the highest order derivative in the given differential equation is dy by dx. There is only one derivative, that is dy by dx. So order of this differential equation is 1. Always remember, order is always defined for a differential equation. We have to just look the highest order derivative present in that equation, and the order of that derivative term is the order of the differential equation. Okay, but to find degree of this differential equation, as the equation is not a polynomial in dy by dx. Why? Because there is a present a term sine dy by dx. Okay, so, and this is a not a form of proper polynomial equation, so we cannot define degree in this case, and degree is not defined. Okay. So there is a many case where degree is not defined, like there is a derivative inside sine function, cosine, exponential, logarithmic, or the derivative is in under square root, or the derivative the power price the power of fractional power, negative power. So in this all case, the degree is not in a proper polynomial form, so we cannot define degree of the differential equation. Okay. Now, NCERT example 1, find the order and degree if defined. Okay. So degree may be defined or may not be defined, but order is always defined. So we have to find the order and degree of the differential equation xy d2y by dx2 plus x dy by dx whole square minus y dy by dx is equal to 0. So try to find. So we have given that xy d2y by dx2 plus x dy by dx whole square minus y dy by dx is equal to 0. So if you observe the given differential equation, the highest order derivative present in the given differential equation is d2y by dx2. Okay. And its order is, we differentiate y with respect to s 2 times, first dy by dx and then d2y by dx2. So order is 2. Therefore, order of the given differential equation is 2. Okay. Now, to find degree, it is a we can observe it is a polynomial equation in d2y by dx2 and dy by dx. The given equation is a polynomial format. We can so now we can find the degree of this ordinary differential equation. As we can see, there is a no term involving sine, log, there is no radicals, and no term involving under square root of derivative. So this is a given equation is polynomial in d2y by dx2 and dy by dx. So now we can find the degree of the differential equation. Okay. And the highest order derivative is d2y by dx2. So take the highest order derivative term, and the power of that term is the or degree of the given differential equation, and that is 1. Power of d2y by dx2 is 1. So in this case, degree is defined, and that is 1. So now given equation, given ordinary differential equation is y triple dash plus y square plus e the power y dash is equal to 0. So at first, find the order of this given differential equation and then find the degree. And to find the degree, at first check degree is defined or not. Okay. So just try. So we have given that y triple dash plus y square plus e the power y dash is equal to 0. The highest order derivative present in the differential equation is y triple dash, and y triple dash meaning differentiation of y with respect 3 times. The order of this is 3. So the order of the given differential equation is 3. Since now to define degree, since given differential equation contain exponential term in its derivative, that is e the power y dash. So it is not in the polynomial form for the derivative terms. So therefore, given differential equation is not a polynomial equation in its derivative, as there is a term involving exponential term. And as I already mentioned that if there is a term involving exponential, log, sine, or the derivative is under square root, any radicals, or the derivative, the power of derivative is some fraction, negative, in all this case, the degree is not defined. If we can convert the given differential equation into a standard polynomial form, then degree can be defined. That means if you can remove the radicals part and it converted into a standard polynomial form, then we can define the degree. But here there is a term involving exponential term, so degree cannot be defined. Therefore, degree of the given differential equation is not defined. Okay. Order and degree of a differential equation are always positive integers. So whatever the order and degree of any differential equation are always a positive integer. Okay, so now we will do exercise 9.1 of differential equation. So the first question is determine order and degree of differential equation d4y by dx4 plus sine y triple dash is equal to 0. So given equation is a ordinary differential equation. Why? Because there is only one independent variable x and one dependent variable, and y is only dependent upon x. So this given equation is ordinary differential equation with one independent variable. Okay, so now we have to find order and degree, and we know order and degree is always a positive integer. Order is always defined for a differential equation. Degree can be defined or not defined. So just try this question. So we have given that y triple dash y difference with 4 times y 4 dash plus sine y triple dash is equal to 0. That is a given differential equation. And to find the order, we just have to see the highest order derivative present in the differential equation, and that is d4y by dx4. So order is 4. So we can easily calculate the order of a differential equation. To calculate degree, that is some tedious task or difficult task, because we have to see the given differential equation, it is a polynomial with respect with derivative terms or not. Okay, as we in this example, so the order of the given differential equation is 4. But since given differential equation contains sine term in its derivative, therefore given differential equation is not a polynomial equation in derivative. And because it is not a polynomial equation in its derivative, we cannot define the degree of the given differential equation. Okay. So to define order, we just have to see the highest order derivative present in that differential equation. But to define degree, we have to clearly observe, is it a polynomial equation in its derivative? It means there is no term present in the differential equation that is involving sine in its derivative, and there's no term involving trigonometric in derivative, log in derivative, exponential in derivative, square root in derivative, negative power in derivative. Then there is a polynomial equation in derivative, and then we can define degree of the given differential equation. Clear? Okay. So question 2 is determine order and degree of differential equation. Y dash plus 5y equal to 0. Simple? Okay. Their answer. So we have given that y dash plus 5y equal to 0, and the highest order derivative present in is y dash. So therefore order of the differential equation is 1. Now define degree. And the given differential equation is a polynomial equation in y dash, as there is no term involving trigonometry or anything else. So the highest power raised to y dash is 1. So to define degree, we see the highest power of highest order derivative, that is y dash, and its power is 1. So degree of the differential equation is 1. Okay. Now determine order and degree of differential equation ds by dt whole power 4 plus 3s into d2s by dt square is equal to 0. Given equation is an ordinary differential equation because there is only one independent variable and one dependent variable, and dependent variable s is only dependent upon t. So this is an ordinary differential equation with one independent variable. Okay. So now we have to find order and degree of this differential equation. So at first you try. So given differential equation is ds by dt whole power 4 plus 3s d2 ds by dt square is equal to 0. The highest order derivative present in the given differential equation is d2s by dt square. There is two term in first one is ds by dt, and the second term in of derivative is d2s by dt square. Okay, and the highest one is d2s by dt square, and its order is 2, as we differentiate s with respect to t 2 times. So the order of the differential equation, given differential equation, is 2. Now we have to find the degree of the differential equation, and the given differential equation is a polynomial equation in d2s by dt square and ds by dt. The power rise to d2s by dt square in the differential equation is 1. So as the given differential equation polynomial equation, and the highest order derivative is d2s by dt square, and the power of dts by dt square is 1. So degree of the differential equation, given differential equation, is also 1. Okay, so this is an example of differential equation with order 2 and degree 1. Second order differential equation with degree 1. Okay. So next question is, determine order and degree of differential equation. Given differential equation is d2y by dx2 whole square plus cos dy by dx is equal to 0. Okay. So what is the order and degree? So we have given that d2y by dx2 whole square plus cos dy by dx is equal to 0. So in this given differential equation, the derivative terms are dy by dx and d2y by dx2, and the highest order one is d2y by dx2. So highest order derivative present in the given differential equation is d2y by dx2, and its order is 2. So the order of the given differential equation is 2. Now to define degree, the given differential equation is not a polynomial equation in its derivative. Why? Because there is present a term cos dy by dx. Okay, so these are not a polynomial equation in its derivative. So therefore degree of the given differential equation is not defined. Next question is, determine order and degree of differential equation d2y by dx2 is equal to cos 3x plus sin 3x. Okay, so just try. So we have given that d2y by dx2 is equal to cos 3x plus sin 3x. So d2y by dx is minus cos 3x minus sin 3x is equal to 0. And the highest order derivative present in the differential equation is d2y by dx2. Therefore, order of the given differential equation is 2. The given differential equation is polynomial equation in d2y by dx2. As there is a present cos 3x and sin 3x. But as I say, the given differential equation is a polynomial equation in d2y by dx2. We to define degree, the given differential equation in the is in the polynomial with respect to different derivative terms. Okay, so the degree of this differential equation is defined because there is a cos 3x and sin 3x, not cos dy by dx and sin d2y by dx2. So this given equation differential polynomial equation in d2y by dx2, and the power of d2y by dx2 is 1. So degree of this differential equation is also 1. Clear? Okay. So next question is, determine order and degree of differential equation y triple dash whole square plus y double dash whole cube plus y dash power 4 plus y the power 5 is equal to 0. Okay, this is your given differential equation. Now try to find order and degree. So given differential equation is y triple dash whole square, that is d3y by dx3 whole square plus d2y by dx2 whole cube plus dy by dx plus y to the power 5 equal to 0. Now here the highest order derivative present in the differential equation is y triple dash, that is the 3y by dx3. So its order is 3. So order of the given differential equation is 3. Now to define degree, as we can see, the given differential equation is a polynomial equation in y triple dash, y double dash and y dash. Okay, so we can define degree. So to define degree, the highest power rise to y triple dash, and that is 2. So 2 is the degree of the given differential equation. Okay, so this example is a third order differential equation of degree 2. Now next question is determine order and degree of differential equation y triple dash plus 2y double dash plus y dash is equal to 0. Okay, so just try. We have given that y triple dash plus 2y double dash plus y dash is equal to 0. That is the given differential equation. And the highest order derivative present in the differential equation is y triple dash. Therefore, order of the given differential equation is 3. And also, the given differential equation is a polynomial equation in y triple dash, y double dash and y dash. So the highest power rise to y triple dash is 1. Therefore, the degree of the given differential equation is 1. Okay. Next question is determine order and degree of differential equation y dash plus y is equal to ex. Okay, so try. We have given y dash plus y is equal to ex. So y dash plus y minus ex is equal to 0. And the highest order derivative present in the differential equation is y dash. Therefore, order of the given differential equation is 1. Now we have to find degree of the given differential equation. And differential equation is y dash plus y minus x is equal to 0. Is it polynomial with respect to derivative? The given differential equation is a polynomial equation in y dash, as there is a presenter term with exponential term, but that is e the power x. That is not exponential with y dash. That is, if there is an equation like e the power y dash, then this is not a polynomial equation. But there is a term with respect to exponential is ex. So the given differential equation is polynomial equation in y dash, and the highest power rise to y dash is 1. Therefore, degree of the given differential equation is 1. Okay. So in today's class, we see what is differential equation, some basic concept like order and degree, and how to calculate order, and when we have to when we can define degree and when not. What is the polynomial form with respect to derivative? Okay,